Hello and welcome to this video on obtaining information from the graph of a function. Okay, so in this video here I'm just going to go over several examples where we're given the graph of a function, and please recall that a function is a relation in which every value of the domain, or every x value if we're looking at graphs, corresponds to exactly one value of the range, right? Or every x value corresponds to exactly one y value. Or if you want to think of it this way too, we're looking at graphs that pass the vertical line test, right? Every vertical line you can draw will intersect the graph at most once. Okay, so what we're going to be doing is looking at graphs of functions and just ask certain questions about them and be able to, and hopefully we can look at those graphs and answer the questions given. That's the title of the page: obtain information. My last example today, though, is going to also be just given a function. Can we make a graph and then obtain information from that graph? All right, so let's begin. So my first example, I have used the graph of the function to answer parts A and B, which you'll see in a second. Alright, so I've got this picture here, right, the light blue. Right, there's this graph where it's going down this way with the little arrow forever, coming up until this little corner here, and then turning, and then it goes flat for a little while up atop here, and then decreases, the value of the function decreases this way down. And the little arrow here indicates it's going down this way forever. Alright. And then I have some special points labeled, right? The point -2, 0 is on this graph, the point 0, 1 is on this graph, and the point 2, 0 is on this graph. But there's infinitely many points. I just pointed out there are only 3 that are specifically labeled. All right. So the first question, part A, is the following. All right. So using that picture up there, determine the domain and range of the function. All right. So remember the domain. When you're asked about the domain and you're looking at a graph on the xy plane, you're looking at the x-axis. Right, you're looking at x values that are being used, and remember the domain is just the set or the collection of all the x values that are used as x values for points on the graph, right? All the inputs, right? All the values of the independent variable that make up the domain. Alright, so look at the x-axis and go low to high. I always like to go low to high. So for the x-axis, that's low numbers to high numbers is left to right. When we talk about the range and look at the y-axis, we'll be going low to high by going from bottom up. Alright, so if I'm looking at the x-axis, you see that -2 is part of the domain, right? It's the x-coordinate of this point. 0 is part of the domain. It's the x-coordinate of that point on the graph. +2 is part of the domain. It's the x-coordinate of this point. But also, can you see that -1? -1 is in the domain. It's the x-coordinate of this point. +1 is the x-coordinate of this point. +4 is the x-coordinate of this point. -3 would be the x-coordinate of this point, right? So can you see how just going back and forth here, no matter what x value I pick, how about this one out here, -7? Well, that is the x-coordinate of some point down here on the graph, right? This goes this way forever. 1,000, right? Go way out to the right. Since this is going this way forever, there is some point way down here that has an x-coordinate of 1,000. But can you see how no matter what I pick for x, no matter what value I pick on the x-axis, there is a point of this graph that has that as an x-coordinate. All right. So the way I would indicate, what I would say there then is that the domain of this function is, you could write it out in words. That's all real numbers. Right, every single number on the x-axis, right, and the x-axis is a real number line, same with the y-axis. So every single number, every real number is part of the domain, is an x-coordinate of some point on this graph. Now another way we could write that is in something called set notation or set builder notation. I draw a little curly brace to start the set, and I'll say the domain consists of all x values, right, values of x, such that, see like the variable we're talking about, then a little colon or a bar like I have here, and then a description of that variable afterwards. So the domain consists of all x as long as x is real, right, or x is a real number if you want to write that out. And then I close the set because I've described here after the bar, I've described all the values that I can use that are part of my domain. Or you could also write your domain, and again we arrange in interval notation, where if I'm trying to describe the entire real number line here, right, every single number is in the domain. In interval notation, and you go low to high, right? Is there a lowest value in the domain? Well, no, there is no lowest value in the domain. If you say -10 is the lowest, I say -1,000. You say -1,000 is the lowest. Well, what about -1,000,000? Right? You can go to the left forever, and every single one of those values is the x-coordinate of some point on this graph. So to indicate that there's no lowest value of the domain, I write the symbolism -infinity, and then a comma to indicate that we got all these numbers out to the left here, all the way up, and then all the way up to the far right as well, right? There is no largest, so I put is there a lowest value in the domain? No, -infinity, comma, and then is there a largest value in this interval? Is there a largest value in the domain? No, like for the same thing. If I say 10 is the largest, because there's a point with an x value of 10, well then you can go to 1,000 and say that's the largest. Then you go to 1,000,000 and say that's the largest. There is no largest value in the domain, so I say that that's infinity. And then you cap these off with either parentheses or a rectangular bracket. The parentheses mean that those numbers at the end are not actually part of the set, and really -infinity and infinity are not numbers. Right? These are concepts. This means I have no lowest, this means I have no highest value in the domain. So because these are not numbers, they are always capped off with parentheses, right, to indicate that these are not actually part of the set. But this interval right here represents everything. Every number on the real number line is part of the domain. Every single number you think of on the x-axis is the x-coordinate of some point on my graph. Wonderful. Now the range. All right, the range is just, you're looking at the y-axis when you're talking the range. Looking at y values, outputs. Right, the range is the set of all the outputs of a function or a relation, but a function is a special kind of relation. Alright, so I'm looking now again, I'm going to go low to high here. Now low to high on the y-axis, we're just focusing on the range. Low to high on the y-axis is bottom up. So look at these, right? So can you see that? Now I've got a couple special points here labeled. 1 is a y-coordinate, so clearly 1, the number 1 on the y, 1 is in the range. 0 is a y-coordinate in these points, so 0 is in the range. But that's not all, right? Just because those are the only ones that are labeled doesn't mean it's everything. -1 on the y-axis, that's a y-coordinate of this point and this point. -4 is a y-coordinate of this point and this point. Go down a few. -7 is a y-coordinate of this point and this point. And can you see if I do this, any y value from 1 downward, right? Just a half or 3/4, or -1.3, -2.75, -pi, whatever. Any y-coordinate from 1 downward is a y-coordinate of a point or 2 points on this graph. So every single y value from all the way down up until 1 is in the range. But you see how everything above 1, all these y values, are not y values of a point on the graph. Everything above 1, there is no graph up here. So all these values above 1 are not y-coordinates of any points on the graph. They do not belong to the range. Alright, so the range here seems to be just all the values 1 or less. And, again, I could write that out in words. All values, all real numbers 1 or less. Or I could say less than or equal to 1. All real numbers less than or equal to 1. If you want to write it out in words, this point down. In that set notation, you could write it like this instead, or you could say the range is, now remember we're talking y coordinates here, values of y, so it's all y values, all values on the y-axis, such that y is less than or equal to 1. And close the set. Again, a little description after the bar here of what values of y are in my range. What numbers are actually y coordinates of points on this graph. Or in interval notation, and as I said before, when you're writing out interval notation, you go low to high, right? Right, low to high, lowest numbers to highest numbers. Well, is there a lowest y value that's in the range? Well, no, right? This graph goes down forever, right? This is technically doing this, right? Forever and ever. Same thing with this here. This is going down forever. So as long as you want to make it so as low as you go, there's always a lower y value that's a y coordinate of points on this graph. So just like before, to indicate that there is no lowest coordinate, no lowest value in the range, I'm going to put negative infinity first, right, comma, and then is there an upper limit to the values in the range? Well, you see how none of the values in the range are greater than 1, right? We've said that a couple times now, less than or equal to 1. So I'm going from negative infinity on the y-axis, all the way down forever, up until 1 on the y-axis. So I have negative infinity, comma, 1. And then I mentioned earlier, you always cap the infinities or negative infinities with a parentheses, right? Because negative infinity is not a number. It doesn't actually belong to the set, doesn't actually belong to the range. But 1 does, right? 1 is a part of the range. 1 is a y-coordinate of these points on this segment here in the graph. So to indicate that one of the endpoints is in the set, is in the range, we put a rectangular bracket, right? So be careful to make nice little 90-degree angles, letting me know that that number 1 is actually part of the set, is actually part of the range. Okay, so that's it for that part. All right, the domain is all real numbers. I can, every value on the x-axis is an x-coordinate of some point on this graph, and the range is all values less than or equal to 1. Right, so all values less than or equal to 1 on the y-axis are the y-coordinates of some points on this graph. Okay, that's part A. Got some information there just by looking at a picture. Part B. Identify the intercepts. All right, so just a quick refresher, you have x-intercepts and y-intercepts for graphs. So an x-intercept is simply any point of the graph that's on the x-axis. And if you're on the x-axis, that means that the y-coordinate must be 0. All right, and a y-intercept, right, any y-intercept for a graph is any point that's on the vertical axis or the y-axis. So it's any point of the graph that's on the y-axis. And if you are on the y-axis, that means you have an x-coordinate of 0. Okay, so the x-intercepts for this particular picture, and again, if you're given a graph, it should be pretty easy to identify them, especially if they're labeled like they are on this one. Look at the x-axis, the horizontal axis. The points that are on the graph, right, they have a y-coordinate of 0 that are on the x-axis are the points -2, 0 and +2, 0, right? So there's some intercepts, right? X-intercepts, points of the graph that are on the x-axis. And y-intercepts, if this graph has any, is again any point of this graph that's on the y-axis, the vertical axis here. And they'll have an x-coordinate of 0. That's this point labeled here, the point 0, 1. And that seems to be it, right? And since it is a function, passes the vertical line test, there should be at most one y-intercept for a function. So that's just the ordered pair, the point 0, 1. And that's it. So these 3 points of the graph, these 3 special labeled points here, are the x-intercepts and y-intercept, or just the intercepts, right? When they say the intercepts, they mean both, right? They don't specify. When they don't specify which, they're talking about both. What are the x-intercepts and y-intercepts of the graph? And that's these 3 points. All right. So x-intercepts have a y-coordinate of 0 on the x-axis. Y-intercepts have an x-coordinate of 0 and are on the y-axis. Hopefully pretty easy to identify, especially when given a picture. Great. So that was it for that example, right? Just a couple simple parts. All right, my next example is another one where I'm given a picture of a function, all right, a graph of a function. Here we go. Now this is not a straight line or anything. It's a nice wavy, curvy function. So here use the graph of y equals f of x, and notice it's labeled here. This is f. This is the graph of f here, this curvy guy. All right, that my finger's following. Use the graph of this y equals f of x, this function f, to answer the following questions. All right, so take a look at this real quick. See how, as I move from left to right here, the value of the function, the y coordinates are increasing up until here, and then decreasing, and then increasing again. I have a few special points labeled. Notice the markings too. The x-axis, every square represents 1 unit. But on the y-axis, every square represents 3 units, right? Again, as long as things are as long as your x and x-axis is consistent and y-axis is consistent, it's still a decent graph. Look at the points that are labeled. There's -3, -15 on the graph. Negative 2 zeros on the graph. -1, 3. The origin 0, 0. 1, -3 is on the graph, 2 zeros on the graph, 3, 15 is on the graph. All right, and it's not just these 7 points that are on the graph. Well, there are infinitely many, right, all along this curve, and there's even little arrows at the ends to indicate, it's going down this way forever and up this way forever. Okay, and well, okay, great. So the first part, right, part A, related to this graph, the graph of this function f. So there it is again. Now remember, this is the y-axis. Find f of -3 and f of 1. Remember what these mean. Remember, f of -3 is what's the value of f at -3. So the number in parentheses here, right, that's the input. That's the x value of the point I'm looking at on my graph. And this is the the y value, right? This is the value of f, or the y value, the output at -3, right? Basically, when x is -3, what's y? Okay, so look at my picture. When x is -3, so I go to -3 on the x-axis, what's y for a point on this graph? That's this point down here, right? When x is -3, f at -3 is the output. This is -15. So from the picture, I'm seeing that the value of f at -3, or the y value when the x value is -3, is -15. All right, so there's one part of the answer, f at -3, and the same thing goes for f at 1. Right? The value of f at 1, same deal, right? The number in the parentheses after the name of the function is the input, the x value. So what this is simply asking for is, what's the value of this function f at x equals 1, or what's the y coordinate of a point on this graph when the x coordinate is +1. So I go to where there's an x coordinate of 1, and what's the point of the graph that corresponds to that? That's this point right here. x coordinate 1, y coordinate -3. So -3 is the value of f at 1. So the value of f at 1, the y coordinate when the x coordinate is 1, from my picture up there is -3. And there, that's it for part A. Very simple. I'm given x coordinates and basically just asked to find their corresponding y coordinates. Wonderful. Alright, and then something similar to what we saw in the last example. Part B is simply, what is the domain of f? So remember, you're looking at the x-axis here. Alright, so the domain of f. We're looking at the x-axis, x values that are actually x coordinates of points on this graph. Remember, this is going this way forever. Alright, and this is going this way forever. And keeps going, it's going to the left, and down, but left very slowly, but it will still go left, 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 left. And the same thing up here, it's going up, but it's also going to the right, but just very slowly. You're not going to the right straight that way, but it's going right, 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 right. So going to the left forever, going to the right forever as I go up, this is going to the left forever as I go down. So can you see how the domain is again all real numbers, right? See how every single value on the x-axis is an x-coordinate of some point on this graph, right? 3 is in the domain, right? It's the x-coordinate of that point. 0 is in the domain, it's the x-coordinate of that point. -1 is in the domain, it's the x-coordinate of that point. But it doesn't have to be just these special label points. -4 is in the domain because it's the x-coordinate of this point here. And 1.5 is in the domain because it's the x-coordinate of this point here, and so on, right? Every single x value, every single value on the x-axis is the x-coordinate of some point on this graph. So again, the domain is all real numbers, so you can write it again this way. All x's is, it's any value on the x-axis as long as x is real, which is just, any number on the x-axis. Or if you write it in that interval notation, that was that, interval from -infinity to +infinity with the parentheses on those, indicating every single value on the x-axis is in the domain of this function called f. Okay, and then part C, same as previous example. What is the range of f? All right, so this time we're looking at the y-axis. Right? So the range of f, looking at the y values. Range of f equals, and then again, I mentioned earlier, this is this is going down forever. This is going up forever. So look at the y. Look at values on the y-axis and which values are y coordinates of points on the graph. So you see how -15 is in the range, right? It's the y coordinate of this point. 0 is in the range. It's in the y coordinate of this point, and this point. So 0 is definitely in the range. +15 is in the range. It's the y coordinate of this point. But they don't have to just be the labeled ones. 9 is in the range because it's the y coordinate of this point. -12 is in the range because it's the y coordinate of this point. -200 is in the range. It's the y coordinate at some point over here. And again, just look at this. It's going down forever, up forever, and there's no gaps in it. There's no holes in it, no spaces, no jumps. So it looks like every y value you can think of is the y coordinate of some point on this graph. So just like the domain, the range is all real y's, all real numbers. So I can indicate that with the set. It's all values on the y-axis as long as y is real, which is basically just everything. Every number on the y-axis, every real number, is part of the range. And same thing, same indicator with interval notation. Right, with the -infinity to infinity and parentheses on the ends, because infinity and -infinity are not numbers. And just indicating to me that every single y value, every single value on the y-axis is a y coordinate of some point on this graph. All right. Then part D. This has 5 parts to it. Same as the last example. Identify the intercepts. All right. So same as before, right? I'll break this up into two parts. We have our x-intercepts are just points of the graph on the x-axis, right? Points on the graph that have a y-coordinate of 0. So that would be -2, 0. All right, that point is on the x-axis. 0, 0 is on the x-axis. And also 2, 0. Nice 3 labeled points here on the x-axis. All right, and then the y-intercept is the point, any point of the graph that's on the y-axis, right, or has an x-coordinate of 0. And that's the point 0, 0 again, right? Now, since I've already written it, right, there's really no need to write it again. I'll just draw a little arrow saying, hey, that point 0, 0, not only is it an x-intercept, but it's also on the y-axis, right? It's the only point that's on both, the origin. So it is also a y-intercept. All right, so the answer to that question would be these 3 points here are the intercepts of this graph, right? They're x-intercepts and the y-intercept 0, 0. Okay, pretty simple there. In the last part, part E, last question related to this this graph is for what value of x does f of x equal 15? In other words, solve f of x equals 15, right? This equation here. All right, so remember how in part A, there was a number inside the parentheses after f, and that number is the x-coordinate. So in part A, I was given x-coordinates, -3 and 1, and asked to find the value of f at those x-coordinates, the y value. This is just the other way around. Part E here is, find the value of x. Find the x value when f of x equals 15. So this value over here, this 15, is a y coordinate, a y value, an output. We're trying to find the input. What goes in here? What input has an output of 15? And you might see in some text too that, when you see f of x or g of x or h of x or whatever, function notation represents your function, that can be also signified by the letter y. So saying f of x equals 15 is the same thing as saying y equals 15. And you're just trying to figure out what x coordinate corresponds to a y coordinate of 15. What input has an output of 15? So I look at my graph. Right? Look for what point has a y value of 15. So we go on the y-axis this time to 15, little 15 there, and the only point corresponding to that y-coordinate of 15 is this point here. And when the y-coordinate is 15, the x-coordinate is 3. Right? So when x equals 3, right, I'll write that in full sentence here. When x equals 3, f of x equals 15. Alright, so this is the answer. Right? For what value of x does f of x equal 15? For what value of x does y equal 15? It's a simple matter of, here's the y coordinate of a point. What is the x coordinate? Look at your picture. Alright, so hopefully all those parts made sense. And then my last example. I have one more where we're not given a graph, but I'm going to make one. All right, and then we'll answer some questions based on the equation and the graph of a function that we're given. All right, so in my last example, I'm asked to consider the function f of x, or y, remember, f of x is the same thing as the output y, equals, and then here's how the output's calculated when the input is x. You take -3 times x plus 7. Alright, now I'm going to make a graph, right? The last two examples we were given a graph. This time I'm going to make one. So let's make a little table. I'm going to do some point plotting. Alright, so here's a table where, my independent variable is x, right? The thing in parentheses, that variable is my input, and then f is my output, right? F of x is the output, the y coordinate. So my independent variable is x, so I'm going to plug in values for x, right? So down one column, got values of x. Down the next column, I'm going to have outputs, what's the value of f at x, and I'll write the whole equation to show how it's calculated. Take negative 3 times x and then add 7. And then down this last column, I'll put up the ordered pairs that we're going to plot. What are they looking like? So every point I'm going to plot has an x coordinate of the the x I choose, and then the y coordinate will be the value of f at x. All right, will look like that. Our ordered pair will look like that. All right, so what numbers do I plug in? Well, if you've seen other videos on that I put up about finding the domain of a function, look that up if you want. But if it's gonna, you can plug in anything you want as long as you don't have a non-real output. As long as you don't divide by 0, and really there's no variables, there's no denominators with variables up here, there's no even roots like square roots or fourth roots, there's no logarithms, so really I can plug in whatever I want for x here. The domain you will see in my graph, the domain will be all real numbers. So what I like to do is I like to plug in some values that are centered around 0. I'll just do like several of them, -2, -1, 0, 1, and 2. You do not have to do these 5. You can plug in whatever other numbers you wish. And I'm just going to plot enough points so that I get a pattern and can fill in the rest of the graph, figure out where, make an educated guess as to where all the ordered pairs that belong to this function are. All right. So the first one, what is the value of f at -2? Well, that's -3 times -2, again just replacing the input x with -2 and then plus 7. That's 13, right? Because that's +6 plus 7, 13. So my ordered pair, the point I'm plotting on the graph will have an x-coordinate input -2, and the value of f at -2 we saw was 13, so I'm plotting that point. All right, and then the value of f at -1 is -3 times -1. I'm not going to write it, so I don't want to get too cluttered in here. I'll just say it. -3 times -1 would be +3, plus 7 would be +10. Okay, so input -1, output +10. The value of f at 0, -3 times 0 is 0, plus 7 would be 7. So input 0, output 7 is the point I'm plotting. The value of f at 1 would be -3 times 1 is -3, plus 7 is +4. So input 1, output 4 would be the point I'm plotting. And then the value of f at 2 would be -3 times 2 is -6, plus 7 is 1. So input 2, output 1. Okay, so I'll plot these 5 points on my graph here. I made some axes with some, with a ruler on some graph paper. If you don't have graph paper, that's fine. Just try to make your axes as straight as you can, and make sure you're consistent with your notches. Here I'm going to have every square represent 1 unit on the x-axis, and I'm going to have every square on the y-unit represent one unit as well. All right, so let's mark off these locations. All right, so the first order pair I'm plotting, I'm going to -2 on the x, 13 on the y. So it's way up here, sorry about that. All right, so -2 on the x, 13 on the y. That is this location. All right. And then I have -1 on the x, 10 on the y. So -1 on the x-axis, 10 on the y-axis, that's this location. Then 0 on the x, 7 on the y. This is one of those y-intercepts, right? It's a point on the y-axis. Has a x-coordinate of 0. And then 1 on the x, 4 on the y, this point. That's this location. And finally in my table here, now this is only 5 solutions, 5 ordered pairs that belong to this function. There are infinitely many. You don't have to do just these 5. You know? 2 on the x, 1 on the y. Alright, and that would be this location. Alright, and here's my graph. Alright. I am going to use a nice little ruler. It looks like, just based on these 5 solutions, it looks as though my other ordered pairs are also going to fall on this nice straight line. Alright, so I will do that here. Draw a nice straight line through all these. There we go. All right, and then a little arrow that way. It looks like I'm indicating it looks like the pattern would continue on forever in both directions. All right, so I'll put little arrows on the ends. Okay, so here's a graph. All right, graph of my function. Now I'm going to answer some questions about it. Answer some questions about this function. All right, so part A. We'll go back to the graph in a second. All right, so is the point -2 for x, 1 for y? Is the point -2, 1 on the graph of the function? Well, no. We saw that the point -2, 13 is on the function, right? That's this point up here. When I look at my graph, right? -2 for x, 13 for y. But yeah, remember how these ordered pairs are looking, right? The structure of the ordered pair is, whatever my input is, -2, and then the output, and this function was called f, the output is what's the value of f at -2, right? So the y coordinate is f of -2 here. So really the question is, what this question is asking is this: is f at -2 equal to 1? Right? This is the same question as that. When they say is the point -2, 1 on the graph, they're really asking, is the value of f at -2 equal to 1? And then you check, what is f at -2? And I did this on the previous page. I did this over here, right? This was -3 times -2 and then plus 7, which was 13, not 1. So the answer to that question is no. And again, you can see it from the graph. You can see it from my little calculation here. The output should have been 13. F at -2 should be 13, not 1. And you're seeing it in my picture. The point, the point -2, 1 is right here. That's this location. -2 on the x, 1 on the y. Clearly not on the graph of the picture of the graph I drew. All right. So the answer to part A is no. Part B. If x equals 3, what is f of x? All right, so notice here they're giving us an x coordinate, and remember f of x is like the y coordinate, right? It's the y value. So if x is 3, what is f of x? And then based on this result, what point is on the graph of this function? Now I do not have that point labeled. It's not a nice solid point like these 5. It's not in my table either, right? They're saying if x equals 3. Well, I have all these points here where x is -2, -1, 0, 1, and 2. So I just need to find one more point here. Now I can get a rough idea, from my graph here. The graph I drew, it looks like 3, -2. Looks like that point is on the graph, right? I'll label it. Here's the point 3. It looks like 3, -2. Just looking at my picture is on the graph. So -2 is the f of x, the value of f at 3. Well, let's test that out. All right, so really another question they could be asking here is, what is the value of f at 3? Right? What is the value of f when x equals 3? So f of 3, all right, let's go back to the function, is replace x with 3. Right? It's -3 times +3, right? Replacing x with 3 plus 7. That's -9 plus 7, which is -2. So when x equals 3, like they're saying, f of x equals -2, right? Or f of 3 equals -2, right? The -2, sorry. But the y coordinate, right? That's the answer right there, -2. The y coordinate when the x coordinate is 3 is -2, and you're also seeing that again in my picture. Right? When I drew the graph, the point, when the x coordinate's 3, f of x, or f of negative 3, is negative 2. Great. Alright, then I have one more here. So this example, part B, the x coordinate was given, and I was asked to find the f coordinate, or the y coordinate, what's f of x. This last part, part C, for this same function is just the other way around, and we saw this in the previous example, where see, they're saying if f of x equals negative 8, what is x? So remember, this here is like saying y equals negative 8. When I say f of x equals negative 8, that's the output is negative 8. What is x? What is the input? And then what? Oh, I forgot to answer that question. I apologize. Let me go back. Sorry. Back to part B. So I found that, when x is 3, y is negative 2, and then based on the result, what point is on the graph? Well, the point on the graph would be, x is 3, y is negative 2, right? That's the second part to that question. My apologies. All right. But yeah, so back here, back to part C, they're saying if f of x equals negative 8, if the output f of x is negative 8, what is the input x? And then what point can you say would be on the graph of f? All right, so let's look at my picture. Look at the graph again. Now we're going this time to the y-axis, right? When y is negative 8, so let's see where that is. So 3, 4, 5, 6, 7, 8. So here's where y is negative 8, or f of x is negative 8. And then I really would have to continue my graph downward. All right, let me try to do this with I'll do this with a ruler here. Let's continue this graph downward. All right, like that. All right, so I actually get a picture, and it looks like when y is negative 8, we're at this point right here on the graph of my line, and that looks to be at x equals, these were 1 unit apart. That looks like 5. That looks like the point 5 for x, negative 8 for y. 5 comma negative 8. So based on the picture I drew, right, it looks as though when f of x is negative 8, x is 5, right? When f of x is negative 8, when the y is negative 8, x is 5. Now I could do that pretty nicely on my graph here because it was graph paper, right? I can very easily see grids, and boxes and corners of boxes. If you weren't doing this on graph paper, right, it would be I would say it would be pretty difficult to guess that when y is negative 8 on this picture, you'd have an x coordinate of 5. So what you're going to do here instead, what if you didn't have graph paper? This right here, this f of x equals negative 8, this is an equation. You're going to solve this for x. When you're saying that f of x equals negative 8, that is an equation. What was f of x? The value of f at x is given by this expression right here. The value of f at x is negative 3 times x plus 7. So when I see this, f of x equals negative 8, f at x can be replaced by negative 3x plus 7. And so asking, or saying that f of x equals negative 8 is exactly the same thing as saying that negative 3x plus 7 is negative 8. Right? Just replacing f of x with how you calculate it, f of x. And then we solve this equation for x, right? So I'd be, subtracting 7 from both sides to get all the variable terms. It's a linear equation next to the first power there. So I'd subtract 7 from both sides, giving me negative 3x equals, and then negative 8 minus 7 is negative 15. And then I would divide both sides by negative 3, right? Or multiply both sides by negative 1/3, same thing. And we're getting our x alone on this side, 1x, and then negative 15 divided by negative 3, right? Negative divided by negative is positive, and 15 divided by 3 is 5. And this is exactly what I said the x-coordinate would be when the y-coordinate was negative 8 on my graph, right? And back on the graph here, we saw that when y is negative 8, when f of x is negative 8, looks like x is 5. And we're seeing that when we solve the equation, right? So you don't need the graph, right? I didn't need that graph there on the graph paper to figure this out. All right, I found out that when the y-coordinate is -8, the x-coordinate must be 5 for this particular function. And then the point on the graph then, right, the question after that, what point is on the graph? Well, the point on the graph you saw was, 5, -8, the ordered pair 5, -8. Or you look here, x equals 5. And then what's the value of f at this x? What's the value of f at 5? Well, they said the value of f at this x was -8, right? So there's the second part of this, part C, right? What point would be on the graph? 5 for x, -8 for y. Right, so just pay attention, what's in the parentheses is the input, right? So like if they say evaluate f at 5, you're plugging in 5 for x. 5 is your input, 5 is your x coordinate. If there's nothing there, right, if it's just f of x equals, and then the number over here is the y coordinate, right? So they're giving me the y coordinate of -8 and asking me to find the x coordinate. So just pay attention to what's what when doing problems such as these, and I'm sure it'll make it that much easier if you really pay attention to what's the input, what's the output, what's the x coordinate, what's the y coordinate in each situation. All right, so you can obtain a lot of information from a graph. All right, what's the domain? What's the range? What are the intercepts? Later that'll be added to. We'll talk about where a function is increasing and decreasing and constant and concave up, concave down. There's lots of other information to obtain from a function. This is just kind of an introductory intermediate algebra video. But also, if I'm given a graph or given the equation of a function, if I'm given an input, I can find an output. If I'm given output, I can find the inputs that correspond to that output. Right? There's lots of things you can do when given an equation or a graph of a function. All right. As I like to say at the end of these, please try the best you can to learn the material, understand the material on your own first before you go looking for help. And I find that people, when they take the time and effort to learn things on their own, it tends to stick with them better. They tend to remember it longer. So read the material, of course. Read the author's examples. Perhaps even try to work out the solutions to an example before you read how the author did it. And then read how the author did it and compare your work with theirs and see if you can learn anything from that, from your mistakes. Obviously work on exercises, practice problems, plenty of them. Look up answers whenever they're provided, just to check yourself, just track your progress. And don't just give up after the first or second attempt at a problem. Try several approaches. And if after several approaches at a problem you're still not getting it, you're still not seeing how to do it, maybe you should read through the material again. A little more carefully, a little more slowly, a little more deliberate. Because perhaps the second, maybe even a third time, maybe because the second or third time you read through it, you might pick up on something, you might see something that you didn't see the first time, or something might click that didn't click the first time, and it'll make the problems that much easier to work on. But if after several read-throughs of the material or several approaches at a problem, you're still not getting it, still not working out for you, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. So ask a teacher, ask a tutor, ask a friend, someone in the class that you know knows the material and is willing to help. Look for supplemental materials online. There's plenty of it out there, I assure you. Look for videos on the topic, perhaps like this one, or other videos out there that are much better than mine. I assure you they are out there and you can find them. But just keep at it. Stay persistent. Keep practicing. Keep checking yourself, and try to stay positive as well. Go into this with a positive attitude. Because if you go into something saying, I hate this, I've hated math, I always hated math, I was never good at it, well, guess what? You're probably going to continue to hate it, and it'll make the learning experience that much worse as you go through. try to go into this with an open mind, thinking I'm going to learn something today and I'm going to enjoy it. I enjoy learning. I'm going to have a positive experience with this, and perhaps you'll even come to like it, and you'll see what kind of a difference that can make. That can make all the difference, a positive attitude. So stay persistent, keep practicing, have a positive attitude, and don't give up, and I'm sure you'll get it eventually. And thank you for watching.